The time of creation till present day, this well-known metal has thought to be humanity's most plentiful, low-cost, and beneficial backbone for the world's high-technology industries. With the expanding world populations and increasingly high appetites for energy and technology, is this metal becoming rare?
Well, the stuff that the people in the 1870s and 1880s at this property thought were mined out, we're going right down through those old underground workings and remining them.
Today, copper is as valuable as silver. As reported in the media, one can see the rising amount of theft of copper wire in the societies we live in. Today's mining operation involves the movement of tons of dirt and rock to be crushed, and includes separating the rich ore soil from the plain ordinary dirt. An environmental concern in the mining industry is recycling the dirt where it is used to backfill old mining pits.
We manage things from a waste perspective, groundwater, air, ensuring that we have monies for reclamation purposes.
Meeting today's needs for copper concentrated ores is a demanding responsibility for the Great Basin mining industry.
Certainly the mining industry is very highly regulated.
Businesses like the Robinson Mining Company are becoming leaders in the use of high technologies and work closely with on-site inspectors, constantly monitoring the environmental issues facing miners. Pure copper is rarely found in nature, but is combined with other chemicals in the form of copper ores such as sulfides, oxides, and sulfates. The color of copper sulfates and sulfides varies from orange and reds to greens and some blues. Many ores also contain significant quantities of gold, silver, nickel, and other valuable metals, as well as large quantities of commercially useless material. Most sulfide ores are taken from huge open-pit mines by drilling and blasting. Let's follow our guide and see the steps necessary to take this precious metal out of the ground.
Now, underneath that crushed ore stockpile, we have a tunnel. And in that tunnel, there's 5 feeders underneath it. And so we operate feeders from underneath that stockpile that load a conveyor belt that goes from the tunnel up into the mill building.
So let's go mining. I could see that this mining operation is by no means small. Look at the size of the shovel they are using to load the raw material. What's that small dozer doing?
So there you've got a rubber tire dozer, again, cleaning the floor for the trucks to back in.
That little dozer does a pretty good job of keeping the area clear of tire puncturing rocks.
And you've got a BE 495 shovel.
Sure enough, looks like he's got a big rock stuck in his bucket. Well, we'll let them deal with it. Let's move on to the next stop and find out what they do with this ore-rich soil.
So this is the mouth of our primary crusher. And it's about a 7-story tall structure from top to bottom. And we have several ways of feeding it. We can feed it with a front end loader out of the ore stockpiles, and we can back in, of course, and dump trucks. The way this crusher works, this design of crusher, it's a rather large cone-shaped opening. And then across the top, it's got what we call a spider, but it's essentially just a brace that goes from side to side. And then underneath it has got a reverse cone that moves in a gyratory manner. And so it works a little bit like a mortar and pestle does. And so what happens is as that cone down below moves, it'll open up and rocks will move down, and then as it comes around, it'll close and it'll crush it.
The material moves underground by way of the 5 feeder lines into the mill building. The mill building contains the necessary machinery and logistical support units to finalize the processes necessary in removing the impurities from the ore. How do you control all this at one time?
It is controlled basically from here. So what we've got is we've got a series of sensors, level sensors, speed sensors, temperature sensors, on-stream chemical analyzers that all report to this series of screens here. And so this guy right here can stop and start pumps, cyclones, mills, crushers, and everything from here, and he can monitor what's going on. The top deck of screens give him the chemical performance, metallurgical performance of the thing, and the bottom set of screens gives him the physical status reports of of the plant.
Let's step outside and take a look at some of the machinery.
That conveyor belt that I showed you that was coming from underneath the stockpile is coming right there. And then it drops through a chute into the mouth of what we call a semi-autogenous grinding mill. So that looks very much like a cement mixer, except it's 32 feet in diameter and 20 feet deep across the barrel. And it's got two 10,000 horsepower motors that drive it. And essentially what it does is it takes that material that's minus 8 inch and it grinds it down to minus 5/8 inch. And the way the cyclone works, the material gets pumped in here, goes around and around. The light stuff goes out the top and the heavy stuff goes out the bottom. So we call this a cyclone cluster. The fine material goes to flotation through those pipes. The heavy stuff goes into the ball mills. These are each driven by a 7,000 horsepower engine, electric motor.
So when it leaves the cyclones, where does it go?
Comes from the grinding side, is delivered through this pair of pipes here to a distribution box. From there it's split into two streams and goes down into our rougher flotation, which is right here below it. And then we'll come down and take a look how the flotation works. This is where the various reagents are at. So here's the hand washing. All of that ground up rock with the reagents is introduced into these two banks of cells. Then you bubble it up with the reagents, and what floats is chalcopyrite. That's what gives it the brassy color. And so that's where we recover our copper, gold, silver, and molybdenum is right here. And so these two banks of cells are taking roughly 22,000 tons an hour and floating copper out of it. That's essentially the rinsing off of selective parts of the dirt. Now the underflow from here is what we call tailing, and that's got the barren rock in it with the copper extracted. We send it over to two big thickeners that I'll drive you by, and that's where we try to get as much water out of it as we can before we pump the tailing down to the tailings dam. That part of the process was rougher flotation. We have two more steps of flotation. These are tower cells, and what they do is they're our cleaner flotation. They polish off the product to make it into as high a grade as possible. And then this set of cells that we're standing on is called scavenger cells. And they're smaller, but they're after the finer particles. So when you look down inside here, you can see it's behaving the same, but the bubbles are smaller and they're collecting finer particles. Now the concentrate, when we finish polishing that concentrate, we send it out to a couple of concentrate thickeners, which are large round ponds outside here, and we get water out of them. That thickened concentrate we pump into this tank right here, and from there we pump it up into a pair of filters. And those filters work like a giant filter press, where it loads it, opens it up, and it's opening up right now. And then we'll dump the dried copper concentrate out of it onto a conveyor belt now, and then we'll load it up with fresh wet material and then squeeze it to get the water out.
I keep hearing about molybdenum. What is that?
Molybdenum showing up in our ore, we have a molybdenum extraction circuit. The molybdenum will show up in the copper concentrate, and we'll store it in a separate tank, and then we'll turn on the molybdenum flotation circuit, and we'll extract the molybdenum out of the copper. So it's got a series of rougher, cleaner, and scavenger flotation cells, but just on a much smaller scale, because it's not treating 22,000 tons an hour, it's treating 800 tons a day. That's why it fits in the corner over here. And we store these up, assay them, and when we've got about 40 tons worth, then we call in a truck and have it shipped off. And molybdenum is used for hardening steel, and we can sell this on the world market. It's currently being consumed at a plant in the south of Tucson, Arizona. Looks kind of steely gray, and this runs about 40 to 50% molybdenum in it. Molybdenum is used to harden steel as well as for a lubricant. So your Mobil 1 synthetic oils is a high molybdenum content lubricant. So those are the kinds of applications that molybdenum is used for.
So where do these materials go from here?